Good day, viewers all over the world. I'm Saluma. Today we're talking about elevation and depression in mathematics. We have elevation and depression in mathematics. So that's our topic today. So please, if you have not watched my video on Sukatuan and Pythagoras theorem, please go and watch it so that I can have a better understanding because I'll be making use of those formulas to solve elevation and depression. Now, just follow me. Like I told you, mathematics is very simple. So I'm going to do justice to this now. Now, see the way I'm standing. If I'm looking straight, I'm looking straight. Mind the word, I'm looking straight. As I'm looking straight, this is me. This is my eyes looking straight. That is called normal vision. I am looking what? Straight. Let's say I have a pole here. So maybe just I'm looking at another person standing equally, the way I'm standing here. Something may happen. Let's say we have this to be the base of a tree. This is a tree. This is a tree. Maybe a Iroko tree or palm tree. You can see that I'm looking at the what? The base, the bottom. Let me use that word. I'm looking at what? The bottom of this tree. If I'm looking at the bottom, as in the same eye, my eye is not looking down, it's not looking up, it's looking straight. That is called what? Normal vision. This is me standing on the floor. This is my eyes looking at the base of this tree. That is one thing. Let's assume that we have a bird here. This is a bird. This is human being. This is a bird. This is human being. And this is a what? A bird. You can see that before drawing this, no relationship between me here and this bird. No relationship between us. But let's assume that all of a sudden I started hearing sound at the top of this tree. Something will happen. My eyes will shift from this place. It will not shift like this to look at what is making that sound. Listen again. I was looking at this place before. Between my eyes, that is the normal vision, the line from my eyes to this tree is what? A perpendicular line. I was looking at the base of this tree. Between my view, this is my eyes, and the base of this tree, this is a normal vision. And I formed a perpendicular line, a perpendicular angle, which is angle 90 degrees, with this tree. This is the top of the tree. It's because this bird started making noise. That is why I have to change from looking from this place to this place. So meaning that I have changed from this angle, I have covered an angle like this. I've covered an angle like this. I've covered an angle in this direction. So this angle that I've covered is called the angle of elevation. Angle of looking up. Let me use that grammar. Angle of looking up for my eyes. Because I've elevated my look. No longer looking straight, but I've changed by looking up. So if I'm looking up, it's called the angle of elevation. But look at this bird. Let's say where I'm here, this bird that you're looking at will also have its own normal vision. It's looking straight. You can see that why this bird was looking straight, the bird couldn't see any human being here. It's just looking straight. Let's assume that while this man is standing here, his phone rings. You know, immediately the phone rings, what happens? This bird will look at down to know what is making that sound. Immediately this bird changing its look from here to this direction, you can see it is no longer looking straight, it's now looking down. This is called the angle of depression. This angle of elevation, looking up, looking down, is angle of depression. Now look at this. I want to bring out this shape now. This is your tree. This is your tree. This is your line of your eyes. This is the eyes of what? Your bird. And this is what? The line between you and the bird. This is you and this is the bird. You have covered an angle. Sorry, the bird has covered an angle called the angle of depression. You have covered an angle called the angle of elevation. If you now look at it, these two lines are parallel to each other. You have two parallel lines. And you now have this line running through the two parallel lines. We have this line running through these two parallel lines. That this line is called the what? Transversal line. Transversal line. Go and watch my videos on what they call it, lines. You understand the meaning of transversal line. Transversal line causes three conditions to happen. One, it makes corresponding angles to be equal. Two, it makes vertically opposite angles to be equal. And three, it makes alternate angles to be equal. So these angles, they are what? Alternate angle. The way you run your sports. One angle in the front, another one at the back. So when you have such kind of occurrence, like this one now, this is your hand, your left hand, your right hand. So you say these two angles are what? Alternate to each other. Because this is a transversal line passing through two parallel lines. So the angle here will be equal to the angle here. The angle here will be equal to the angle here. So you will now say that the angle of elevation is equal to the angle of depression. So if angle of elevation is 60 degrees, so it means the angle of depression will also be what? 60 degrees. I think we have proved that. So it's as simple as A, B, C. So we are going to be solving a whole lot of questions on angle of elevation, elevation and depression. Because after this, I would like to teach us what they call this topic. I always give them problem in mathematics. Okay, I remember as I'm doing this. So, like this, let me give us a question to solve. Or let me explain further before I give us a question to solve. Maybe I will have to do another video where I will just be solving questions as regards to elevation and depression. But let me do justice to the explanation, because what they will always be talking about in your elevation and depression is cliff, your ship, sailing, blah 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 blah. Just understand what they are saying. You will interpret it and you're going to solve it. At times they can say a man is standing on a platform that is 20 meters high. Now, let me just write the question. A man is standing on a platform that is 20 meters high. If the man sights an aeroplane, at an angle of 60 degrees, and the distance of the plane, of the aeroplane, sorry, of the aeroplane to the ground is what, 250 meters. Calculate the distance between the man, calculate the distance between the man and the plane. Calculate the distance between the man and the plane at the ground level. At the ground level. Now let's solve it. When you are solving mathematics, the first thing you first do is to bring out the preambles, as in those things that you are given. So from what you are given, you can determine what you are not given. So like here now, they say man is standing on a platform that is what, 20-meter high. So meaning that this platform is standing on the ground. This is the platform. Let's say this is the ground. This platform is 20-meter high. This is the man. And I said, if the man sights an aeroplane at an angle of 60 degrees, definitely aeroplane will be up at an angle of 60 degrees. This angle of elevation. This is normal vision. I hope I'm clear. This angle of elevation, because this man we initially have a normal vision. But because of sound of the aeroplane, it has changed its look from normal vision to angle of elevation. So if the man sights an aeroplane at an angle of elevation of 60 degrees, and the distance of the aeroplane to the ground is 20 feet. This is the plane. So they now say the distance of the aeroplane to the ground is 250 meters. So this is now the ground. This is distance of the aeroplane. This is aeroplane. This is the man. So distance of this aeroplane to the ground level, not to the platform, to the ground level, is what? 250 meters. 250 meters. So the last step should determine the distance between the man and the aeroplane. This is the man. This is the ground level. The distance from here to here is also the same thing that the distance from here to here. It's just like a parallel rectangle. So the opposite sides are equal. So if this place is 20 meters, what will be this place? This will be 20 meters. So meaning from here to here will be what? 250 meters minus 20 meters. So that will be 230 meters. So this place is 230 meters. So no longer 250 meters again. So we are breaking everything down. So from here to here is 230 meters. From here to here is 20 meters. So from here to here is 250 meters. So they said we should calculate this place. So we can say let this place to be what? X. So if you like, you can now redraw out the triangle again. So if you redraw this one out, you are going to have this. So I want to determine X, because that's the distance between the man and the aeroplane from the ground level. So this place is 230 meters. So this is 60. So how do I determine X? You know, like I told us, you can only apply Pythagoras theorem when you know two sides. But here we are giving just only one side. So you have angle. You now find the relationship that will connect this side and this side together. So let's label. Don't forget, this is your right angle triangle from here. So this is the perpendicular. Perpendicular. So we now have this to be what? Your hypotenuse. This is your opposite. And this is your adjacent. So what relationship is now connecting adjacent and opposite together? Don't forget. So So in all this now, when you find opposite and adjacent together, definitely it is not sine. Definitely it's not qua. So it's tan. So it's now going to be tan 60 degrees is equal to opposite, which is 230 meters, all over adjacent. So we now have this. Let me just rub off this side so that we can just manage it. So now have, from here, when you cross multiply, you have x to be equal to tan x is equal to 230 all over tan 60. So x is equal to 230 all over, what is tan 60? Me, I don't know it offhand. I'll quickly draw. I'll just quickly draw. It's 60 I'm looking for. So this is 60. Don't forget this is root 2. This is 1 and this is 2. So it's tan I'm looking for. Tan is equal to opposite all over adjacent. So what is my opposite there? This is my hypotenuse. This is my opposite. And this adjacent. What I mean is opposite and adjacent. So tan 60 is what? Opposite, which is root 2, all over adjacent, which is what? 1. So we now have that to be root 2 over opposite, root 2 all over adjacent, 1. So that's root 2. So I will now have x to be equal to 230, all over tan 60 is what? Root 2. So you cannot leave your answer as root. You have to do what? Rationalize. So when you rationalize, you now have to do what? Okay, how did I tell you you're going to rationalize? You multiply both the numerator and the denominator by the denominator. What's the denominator? Root 2. That will be times root 2 all over root 2. So we now have x to be equals to 230 root 2 all over root 4. So square root of 4 is what? 2. So we have 230 root 2 all over 2. So 2 goes to 230. That is 1 in 13. So sorry, 1 in 3. That is 1. Then in 10. So we have 115 root 2. So the answer is 115 root 2. So it means that this place is what? 115 square root of 2. So there is no magu or magic to this. Once you adopt the principle, you are bound to arrive at same end. So we're going to still solving more questions on this. Thank you very much for listening, but make sure that you subscribe so that you can be updated on my new topic. Anytime I bring up any new subject, you'll be aware. Make sure you share this to others so that they can also be part of this program, part of this benefit you are enjoying. As you do so, God bless you. I remain Sir Lidwan. God bless.